Hello and welcome back to elementary algebra. We are going to talk about substitution method for solving the equations with two unknown variables x and y. The system is going to look exactly the same as last time, but this time we're not going to graph. We are going to use algebra to solve these equations by shoveling x's and y's around. Now let's immediately learn how is this done. Again, you are going to have either one solution, no solution, or infinitely many solutions. And let's take a look at the way we solve these systems. So let's say you have 2x plus y equals to 10 and y equal 3x. So let's say this is the system, and you know that you can graph this, and hopefully they intersect at the point that you can easily read. But problems where they intersect to the point that you can easily read are very rare. Very rare. Usually the answers are decimals and fractions and so on. And that's very difficult to read from the picture. So we generally don't use graphs to find precise answers. We use them more as a guideline to see what is going on when we have to make quick snap decisions. But if you want precise numbers, right, the substitution method would work much better. Now, substitution method is literally what the word substitution means. You see that you have the two equations, both have x and a y. The second equation has y equals 3x. So what I'm going to do is I'm going to substitute that into the y from the first equation. That's it. So now this first equation is going to look like 2x plus, instead of y I have my 3x from the other equation, equals to 10. So as you can see, I substituted 3x instead of y, so I took the y out, and we have this. So now it's 5x equals to 10, and divide both sides by 5, x equals to 2. So we were able to compute the value for x by eliminating y from the equation using substitution. Once you have x, you can use the other equation to compute y, and for full credit you list this as a 0.26, which is your answer. Technically the lecture is over, right? Because the only thing that we are learning now is that you can plug one equation into another. So this y is the same y, and you are replacing y with what y is. And in this case, it's 3x. So that's why I used a different color here, so you can exactly see what happened. I am copying the first equation. This equation is the same equation, except y is replaced with 3x from the other equation. So you can still see 2x plus y equals to 10, but y is the 3x. Let's do another example. They're all the same. You have negative 2x plus 3y equals to negative 8, and then x equals to 3y plus 1. Again, two equations, two unknown variables, x and a y, and the way to solve this is to replace a variable with the expression. So in this case, as you can see, it is x that it's equal to this mess, which means that stuff goes for x this time, right? Because x equals 3y plus 1. So what do we have? This equation turns into negative 2 times, here is your 3y plus 1, right? You see that 3y plus 1 is x, right? So it goes for that x. So you just substitute in, and then you copy the rest of the equation. Plus 3y. So this is your x. But we use the other equation to replace that x with 3y plus 1. That's what it means to substitute. You substituted 3y plus 1 for x. And now you have a basic chapter 2 equation. You just plow through these calculations and you are done. So negative 6y minus 2 plus 3y equals to negative 8. You distribute negative 2. Then you combine like terms. So negative 6y and 3y, that's going to be negative 3y. Minus 2 equals negative 8. Add 2 to both sides. That gives you negative 6. And when you divide by negative 3, you have y equals 2. So we were able to compute y because we eliminated x's. And the entire equation was only in terms of y, and we were able to go through all of those calculations quickly and get us. I mean, this is chapter 2. There's nothing special about this. You've solved these equations 1,000 times so far. The only thing that you are learning today is that if you have two equations given as a pair, you can plug one equation into another to eliminate a variable and just go through. All right, now we need to, when we have y, we need to calculate x. Well, that's not going to be a problem because you have the equation that calculates that. So this equation, right? X equals 3 times y. Now y is 2. So that's 6 plus 1 is 7. And the answer is 7, 2. Right? X comma y. So we have one solution, right? And that solution is 7, 2. Now, these problems can have also the situation when there is no solution, or when there are infinitely many solutions. So we are going to, let's take a look at 3x plus y equals to 4 and 6x plus 2y is equal to 6. Okay. Substitution now is not easy like in the previous two cases. If you notice the second equation in the previous two problems, second equation was always either x equals everything else or y equals everything else. You don't have that now, which means that you have to first flip one of the equations and then you get to do the substitution. Now, this is the step where we say, look for single x or y and flip that equation. Now, when you take a look at your 4 x's and y's that we have here, only one of them is single, and that's obviously this y over here. All other ones, right, this is a 3x, this is a 6x, and a 2y. So look for a single x or a y, and I'm just going to point the arrow to make that clear. So solve for the single one. Flip the equation around Okay, and flip that equation to solve for that single variable. So from the first equation, I can write, well, 3x plus y equal 4. I can subtract 3x. Again, this is formulas from chapter 2. And you have y equals 4 minus 3x. So we created that equation. It was given to us in the previous two examples, but now in this example we had to figure it out. Now, remember, we use the first equation to flip. That means that this has to be plugged into the second equation. You can't flip the first equation and then plug y into itself, right? You have to plug this into the other equation. So sometimes your single x or a y is going to be in equation number 1. Sometimes it's going to be in equation number 2. No matter where it is, once you have that single x or single y, you flip that equation and always plug into the other equation. So that's, I hope that you will rewind this few times on YouTube to make sure that you have this straight. So whatever equation has the single x or y, you flip that equation and then you plug that equation into the other equation that you haven't used before. So now in our case, over here we have our equation number 2, which says 6x plus 2 times, and now our y is this 4 minus 3x, and that all is going to be equal to 6. So if you compare these two equations, it's the same equation. It's the same equation except the y is replaced by 4 minus 3x. And now all we need to do is to solve this. We have 6x plus, when I distribute, I have 8 minus 6x equal to 6. Ooh, we are getting here into a problem, as you can see. When I combine my like terms, they cancel, and I get 8 equal to 6. Well, that's no bueno. Which means no solution. You see that x got eliminated from the problem. We eliminated y by plugging in the expression with x, and then x got eliminated as well, and we got this garbage 8 equals to 6. We know that 8 is not equal to 6, and because we have 8 equal to 6 nonsense, we claim no solution. Now, if you are to graph these two, you will get parallel lines, because that's what it means to have no solution. So if you go and you graph this, you will find these parallel lines, and the parallel lines say no solution graphically. But when you are calculating algebra, when you have what I call mathematical nonsense, it's called mathematical fallacy, but I'll call it mathematical nonsense, of 8 equals to a 6, that means no solution in our case. Let's do one more and call it a day. Now we will again practice this, and we'll do word problems next class. So now let's just practice one more of these so you can at least start the homework. Now the next class is in 2 days, so you know we'll see you there. Let's find another vanilla example. This one has a little bit larger numbers, but we'll live. X minus 5y equals to 26, and 2x plus 6y equals to negative 12. So what we learned in a previous example was look for single x's and y's, right? Look for single x's and y's and solve for that variable. So when I look at the both equations, I see that the x on top is single. So I will flip the top equation by adding plus 5y on both sides, right? Into x equals 26 plus 5y. You can also say 5y plus 26, whatever. But we turned that equation into x equals equation. So since that happened in equation 1, we will plug this mess in the equation 2. So now my equation 2 is 2 times the mess plus 6y equals negative 12. So this is your equation 2. Now instead of x, I am substituting 26 plus 5y. And then we go and we compute. 2 times 26 is 52 plus 10y plus 6y equals to negative 12. Combine like terms into 16y. So 52 plus 16y equals negative 12. And then we subtract 52. 16y is equal to negative 64. And when we divide by 16, y equals negative 4. We were able to figure out that, and now we have that x is equal to 26 plus 5y. So x is 26 plus 5 times negative 4. So x is 26 minus 20, x is 6. So the solution is you list x first and then negative 4 second, because it always has to be x comma y. Fortunately, a lot of mistakes like that on a test because you're not paying attention, right? Make sure you always list y second. I don't care if you computed y first or second. That doesn't matter. What matters is that the point is always x comma y. So x has to be listed first, y has to be listed second. So here's my y and it's second. Here's my x and it is first. It's always like that. Always x comma y. And since we are since this is going to, right, since we are done here, we can check, right, and see if this stuff works. So the two equations are x minus 5y, so x is 6, minus 5 times y is negative 4, and that should be 26. So we have 6 plus 20 equal 26, 26 equal 26, and it checks out in our first equation. The second equation is supposed to be 2 times x, which is 6, plus 6 times y, which is negative 4, and that whole thing needs to be negative 12. So 12 minus 24 is equal to negative 12, and there it is. Negative 12 equals negative 12. That checks out as well, meaning that the solution that we have, 6 comma negative 4, is perfect. So that's it. I hope you are not disappointed. We are going to do problems with fractions and some word problems next class to finish chapter 4. And we will also talk about the exam, so make sure you are there next class if you want to be the part of choosing the weekend for exam 2. We have enough material covered to have exam 2. So exam 2 is on chapters 3 and 4. I know it's only 7 sections, but we'll add the word problems from the first test. So it's technically 8 sections. And then the next exam will be chapters 5 and 6. Right, then it's going to be exam 4 and the final. So we still have long way to go. Please don't get relaxed, and keep doing the homework and practicing these things. And we'll be back on Thursday. Questions, concerns, anything? I'm just gonna say bye to the